Welcome to class first year chemistry. Today we will discuss electrolysis or working of an electrolytic cell. What is electrolysis? Electrolysis is an electrochemical reaction that occurs when current is passed through an electrolyte. The electrolyte, when current is passed through it, ionizes into ions. For example, when aqueous solution of sodium chloride, when current is passed through sodium chloride solution, it's break up into sodium ion and chloride ion. So electrolysis is the breakdown of an electrolyte in presence of electricity. Electro means electricity and lysis means breakdown. So electrolysis is breakdown of electrolyte in presence of electricity. This is the basic reaction that keeps on taking place in an electrolytic cell. The electrolysis takes place in an electrolytic cell. You must know, when molten salt is electrolyzed, products are predictable. We know that what sort of products are going to be produced at anode and cathode. But if when aqueous solution of salt is electrolyzed, hydrogen and oxygen gases appear at cathode and anode respectively. So we are to discuss two types of electrolysis. Number one is when electrolyte is in fused or molten form. Number two is when electrolyte is in solution form. So let's start when electrolyte is fused salt or molten salt. When fused salt is electrolyzed, it ionizes into cation and anion. For example, when sodium chloride salt is ionized, is electrolyzed, it ionizes as sodium ion and chloride ion. Cation moves towards cathode. Because cation has positive charge, cathode has negative charge. Opposite charge attract each other. Similarly, anion moves towards anode because anion has positive charge and anion has negative charge and anode has positive charge. Oxidation takes place at anode, which is loss of electrons. So, chloride ions lose electrons at anode and reduction takes place at cathode. Gain of electrons. So sodium ions become attached on cathode and gain the electrons coming from chloride ion, coming from anode. Therefore, chlorine gas is produced at anode and escapes out of the cell. And sodium metal, which is purified from the salt and extracted from the salt, is now collected in the tank and collected out of the cell through an outlet. This is an electrolytic cell which consists of an anode, cathode, and the electrolyte molten sodium chloride. And the battery is connected to both electrodes. Current flows from positive to negative terminal of the battery, as shown in the diagram. When battery is turned on, chloride ions appear on anode because they both have opposite charges. And sodium ions appear at cathode as sodium ion has positive charge and cathode has negative charge. Let's see the reactions. At anode, as usual, oxidation will take place. Oxidation means loss of electron. So chloride ions will lose electrons as they have more oxidation potential. So they become chlorine gas at anode. Now at cathode, Reduction will take place at cathode. Reduction takes place, which means gain of electrons. So sodium ions appear at cathode and accept electrons coming from chloride and becomes reduced and produce neutral sodium metal. This is an unbalanced equation. We multiplied it by 2 so that it can be balanced equation. So we get balanced equation. 2 sodium ions plus 2 electrons give us 2 sodium metal. 2 atoms of sodium metal. Overall reaction is sum of all these reactions. So we get this equation. We cancel out the same species on both sides of the arrow. So we cancel out 2 electrons on left hand side and 2 electrons on right hand side of the arrow. So that we get the net ionic equation. Here you can see that the products are only sodium metal and chlorine gas. So in this way, whenever we electrolyze a fused salt, products are predictable. When battery is turned on, sodium metal is collected in the tank, in the container, and chlorine gas appears at anode and escapes out of the cell. Chlorine gas is produced as byproduct, which can be used for different purposes, and sodium metal is extracted from here. These reactions are useful in extracting or purifying metals from their salts. For example, magnesium can be purified from magnesium chloride. Now let's talk about when electrolyte is in solution form or in aqueous solution. Let's have an example of aqueous solution of sodium nitrate. Sodium nitrate is a salt. When current is passed through the solution, sodium nitrate ionizes into sodium ion and nitrate ion. Since it is an aqueous solution, it also contains water molecules. So on passage of current, water molecule also ionizes as hydronium ion and hydroxyl ion. Now let's see the reactions. At cathode, reduction will take place. Reduction means gain of electrons. So hydronium ion being positively charged get attracted towards cathode and gain electrons because they have more reduction potential. So they produce hydrogen atom and water molecule. Then two such hydrogen atoms combine to produce hydrogen gas. Thus it is clear that hydrogen gas is produced at cathode. Now at anode, oxidation occurs. Hydroxyl ion from water oxidize themselves as shown in the equation. They lose electrons and become neutral atoms. Four such hydroxyl ions oxidize themselves to produce 1 mole of oxygen and 2 moles of water. So oxygen is produced at anode. When battery is turned on, oxygen appears at anode and escapes out of the cell. And hydrogen appears at cathode and escapes out of the cell. Both these gases have different purposes, different uses. They can be collected and used for various applications. Why so hydroxide instead of nitrate ion is oxidized at anode? You can see here that both hydroxyl and nitrate have negative charge and can be attracted by anode, but only and only hydroxyl ion is oxidized. Same is the case with hydronium and sodium. Both sodium and hydronium ion have positive charge and cathode has negative charge, but only hydronium ion is attracted by cathode. Reason? Reason is that it is because hydroxyl ion has more oxidation potential than nitrate. It means that hydroxyl has more ability to lose electrons than nitrate, and it is because hydronium ion has more reduction potential than sodium. Hydronium ion has more ability to gain electrons than sodium metal. So therefore, hydrogen gas evolves at cathode and oxygen gas evolves at anode. So you can see here what is difference when molten salt is used and when aqueous solution of salt is used. So these reactions are useful for production of hydrogen and oxygen gas. This is how an electrolytic cell works when salt is in fused form and when salt is in aqueous solution form. Thank you for watching this video.